Okay, in this demonstration I'm going to illustrate a couple of Microsoft's Excel's functions that can help you use linear regression functions or use linear regression in other ways to determine a cost function or perhaps a beta coefficient, essentially to derive an equation for a line. Okay, in this example I'm going to use the New York Stock Exchange historical data by year, and I think the data is just made up, as our independent variable, and our dependent variable will be the returns of stock A. Okay, now you could use this to develop, using linear regression, a line to come up with what that function is, using any independent variable or dependent variable. So this could be, as an example, this could be number of units produced, and this could be total cost, and we would develop a cost function. Or if we ran a lemonade stand, this could be the temperature of the day, and this could be how many glasses of lemonade we sold. Alright, to start this, I'll highlight the range of data that represents our independent and dependent variables. And then I'll go up to the Insert menu, click on the Scatter graph. Okay, these are our charts, they're called in Excel. I'll click right here. And then you're going to get a graph that looks something like this. And let me slide it over so you can see it. I'll put it over our data, but that's okay. Now, you may get a title when you do this, because I've run through this before. I've taken off the title. I think Excel remembers that. But you may get a title on the top of graph, on the top of your chart. Alright, so we really don't need the series label for purposes of this illustration. Then I'm going to select the data points and right click and click on Add a Trend Line. Now, once I click on Add a Trend Line, for line style, I like dotted using linear regression, but you could leave this alone. So I'll make that a dotted type, and then I'll hit Close. But what I do want to bring back, let me hit Add Trend Line again, is there's some useful equations at the bottom. We can put the display equation on the chart and also put the R-squared value, which is a measure of how well our linear regression formula actually fit the data, or how well the data fit the linear regression formula. You can see it goes both ways, and it's a measure of 0 to 1. Okay, as soon as I hit Close, we get the line. Oh, I didn't get the dotted line here. Let me format that again. I think I picked line color instead. I want this dash. Oh, I never locked it in. Hit Close, and now we get dots. Though it may be hard for you to say it, it really is dots. Okay, and there's our equation right there. Maybe we can make this a little bit bigger so you can see it. There we go. And it's a little bit easier to see. Let me sort of see if I can move this over a little bit. There it is. Got to get it to Excel to look like that. Okay, so what we have here is, I want to raise it a little bit so we're not sitting right on the line, if I can do that. We have an equation that says the dependent variable will be equal to 0.565 times the independent variable plus 3.7398 with an R-squared value of 9.9596. Now, R-squared goes from 0 to 1, with 1 being a perfect fit and 0 being no fit. So this is telling us on a scale of 0 to 1, we've got a pretty good relationship here. And what that tells us also is 3.73, or an average return of 3.73, is where the line crosses the y-axis. If this were a cost function, that would be the fixed portion of the cost, and the slope of the line would be the variable portion of the cost, which is 0.565. Okay, now also, if you were using this to measure a beta coefficient, that 0.565 represents the beta coefficient. Alright, now that's how you can do this using graphs. Now let me move this off to the side. We'll see a little bit of it, but I want to show you another way that you can do this by using two functions. There is one function called a slope and another called an intercept in Excel. And we could go in here and type equal slope, hit the left parentheses, and then I like to go up to the formula bar and click at that point where I come up with the function arguments, and it gives us a nice explanation of what it is. So the known y's are these values right here, and then I'll lock that in, and then the known x's are right here, and I'll lock that in, hit OK, and you'll see I've got the same 0.565 that we saw right here. Let me round that to 3 decimal places. Okay, actually I want to round it to 4, and I'll format the next one to do the same. So there's my beta coefficient, or the slope, or the variable portion of a cost function, right? That represents the change in x as we try to make a prediction for y. Okay, and then using intercept, I can type in equal intercept. Now let me show you another way to get to this. You could come up to here and go off of the formula bars. You're going to look for statistical. It's not one of these, so we go to more functions, go to statistical, and then you have a whole list of them. And then I will slide down till I see intercept. There's intercept, and it brings up my function arguments. And again, my known y's are these ones right here, and my known independent variables, or the x's, are those right there, and I come up with 3.7398, which again is where we cross the y-axis, representing fixed cost if this were a cost function, but certainly represents the y-intercept. Okay, so there's 2 different ways you can use linear regression with Excel. Thanks, everyone.